everyone, so today we'll be talking about how do solar panels work. So first, what is a solar panel? Well, a solar panel is a device that can convert sunlight into electricity. Now when we look very closely at a solar panel, we can see that we have these blue rectangles which we call photovoltaic cells. And photovoltaic means converting light to electricity. Okay, so now I want to review about the atom. So an atom has three parts, and the three parts are the electrons, which have a negative charge, the protons, which are these red ones that have a positive charge, and the neutrons, which have a neutral charge. Okay, so now let's talk about the two main types of materials. So the two main types of materials are conductors and insulators. So conductors allow electrons to flow through them, and insulators do not allow electrons to flow through them. Now in between we have something we call semiconductors. And silicon, this is silicon over here, silicon is an example of a semiconductor. And semiconductors can allow electrons to flow through them quite well, but not very well. So the good thing about semiconductors is that you can increase or decrease the conductivity of them. And to do this, you need to dope them, and we'll talk more about them. Okay, so over here we have the sun, and we have these solar cells, which is another name for photovoltaic cells. And what the sun will shine light or emit light onto these solar cells. And when we look very closely at this light, we see that there's these things which we call photons. They're the particles that make up light. Okay, so now let's look more closely at the solar cell. When we look very closely at the solar cell, we see that we have two parts. We have the p-type solar cell and the n-type solar cell. So the P in p-type solar cell stands for positive, as it's positively charged, and the n-type solar cell, the n stands for negative, as it's negatively charged. But what gives it the charges? So now we have to look at the periodic table for that. Okay, so this is a quite blurry periodic table, but this is the periodic table of elements. And over here, the number that you see above each element is basically the amount of protons it has, and it is called the atomic number. And that's what makes each of these elements different from each other, the amount of protons. So the amount of protons is usually the same amount as the amount of electrons, but it can differ. And that's not usually the case, but it can be the case. Now we're going to assume that that's not the case, and the protons and electrons are equal amounts. So silicon is over here. It has an atomic number of 14, which means it has 14 protons, which also means it has 14 electrons. The other ones I want you to remember are phosphorus, which is right over here, and phosphorus has 15 protons, which means 15 electrons too, and boron, which is over here. It has 5 protons and also 5 electrons. So let's look at silicon. So silicon has an atomic number of 14, and this is how it looks like. So we have 4 electrons in the outer shell. And we have a total of 15, but when we look, we can see 4 on the very outer shell. And those are called the valence electrons. So here we have 4 valence electrons. And valence electrons are the electrons that silicon just wants to get rid of. It'll do anything to get rid of those electrons. Then we have phosphorus. Phosphorus has an atomic number of 15, so it has 15 electrons, and it has 5 valence electrons. And then lastly, boron has an atomic number of 5, and it has only 3 valence electrons. Okay, so back to our solar cell. Now we're going to do something we call doping. If you remember from our semiconductor, this can increase or decrease the conductivity. So in the n-type solar cell, we're going to dope it by adding phosphorus, and the p-type solar cell, we're going to add boron. So we have silicon in both, but we're adding phosphorus to the n-type solar cell and boron to the p-type solar cell. Now, phosphorus has extra electrons. So we're adding extra electrons to this, which therefore gives it a negative charge. The positive one, however, we are giving it extra electrons, but it's not as much. The solar cell wants to have an overall neutral charge. So what we call this that we have few holes. And the holes are the missing valence electrons that if we did have, it would be neutral. Okay. So since this is positively charged and this is negatively charged, you could think of it like a magnet. South attracts with north and south repels with south. The same thing. You could think of the south as negative and the north as positive. Positive attracts with negative and negative repels with negative. So they're going to attract. So over here I have a different visualizing way, and that is that we have some electrons here and we have the holes here. Now, the holes are just missing valence electrons, not protons. So the electrons and the electrons really want to fill up the missing valence electrons to make it neutral. So they're going to meet with each other, and this is called a p-n junction. And now you might be thinking, why are we doing this n-type and p-type? Well, the important thing is for light. Light will do something, and light is made up of photons, and these photons will separate the electrons from the holes. And by doing that, the electrons cannot get to the holes, but they really want to do it. So this is called the photoelectric effect, using light to push away the electrons. Now, we can take advantage of this. We can put a circuit like this, and it connects to the positive side. So the electrons are like, hey, we can get to the positive side. And they're just going to go like this and get as fast as they can. But then they'll power up the light. But there'll be some leftover electrons. And they will just go up and get to the positive side. But now you're like, but then will all the electrons get over? I mean, all the leftover electrons will get to the positive side. We won't have any more electrons. Well, for that, light comes again. So the photon will basically separate the electron again from the positive side. So the electron is like, I'm going to go again. And it'll go across it again. And that's how we can power our light. Okay, so thanks for watching. I hope you enjoyed this video. And you can watch our batteries video over here and our capacitors video over here. And subscribe and stay tuned. Bye!